Welcome back to part 4 of the differentiation series. Today we are going to discuss problems based on logarithmic differentiation. Now, when do we do logarithmic differentiation? We will do logarithmic differentiation when we have a situation where we have a function raised to another function or a variable raised to another variable. Now, I've taken an example here, y is equal to x raised to x. So it's a variable raised to another variable or a function raised to function. Now, if we had a variable raised to a number, say for example x raised to 4, the derivative would have been 4x cubed. If we would have a number raised to a variable, say for example 4 raised to x, the derivative would have been 4 raised to x into log 4. But when we have a function raised to function, as in this case, there is no formula to derivate such a thing. So when we have a function raised to function, we will take logs on both sides. That is precisely what logarithmic differentiation is all about. We involve logs in the problem to simplify this kind of a situation. Let's see how. So when we take logs on both sides, the left hand side is log y, the right hand side the power comes down, so x into log x. So the left hand side is a chain rule which will derivate, and the right hand side is a UV rule which will derivate alongside. So let's differentiate with respect to x. Log y, the derivative of log y will be 1 by y. Remember, we are differentiating with respect to x, so y is a secondary variable, it's not the primary variable. So log y, the derivative will be 1 by y, but into the derivative of y with respect to x, so that's d by dx of y, which also is written as dy by dx. The right hand side on the other hand is a UV rule, so we do x into the derivative of log x, which is 1 by x, plus log x into the derivative of x, which is 1. Here x and x got cancelled, you get 1 plus log x, which is here in the bracket, and the y is transferred on the other side, so dy by dx will be y into 1 plus log x. Remember, y is x raised to x, so we substitute x raised to x in place of y, and we get x raised to x into this 1 plus log x as dy by dx. Let's take some more problems based on this logarithmic differentiation method. So question number 1, we have y equal to x raised to sine inverse of x. Again, a function raised to a function. So we take logs again on both sides. Left hand side log y, sine inverse of x, the power comes down into log x. So the left hand side, as usual, 1 by y dy by dx, 1 by y dy by dx on the left hand side. Right hand side UV rule, so sine inverse of x into log x, derivative is 1 by x, plus log x into the derivative of sine inverse of x. We've done in the earlier video 1 upon root 1 minus x square. We just transfer this y on the other side, which happens to be x raised to sine inverse of x. We get sine inverse of x upon x plus log x upon root of 1 minus x square in the bracket, and that is your answer. Move to the next question. You have y equal to sine x raised to x. Again, a function raised to function. We've taken logs on both sides. Log y is equal to power comes down, so x into log of sine x, derivate both sides, 1 by y dy by dx is equal to x into derivative of log sine x is 1 upon sine x into the derivative of sine x is cos x, plus log sine x into derivative of x is 1. So we transfer this y on the other side. Remember, y is sine x raised to x, so that is sine x raised to x outside. In the bracket we have x into cos upon sine is cot x plus log of sine x in the bracket. That is the answer. Moving on to the next problem. Now this isn't function raised to function, but if you see the expression, you have y equal to x raised to 5 into e raised to x square into root of sine x. Now, what is the reason for taking logs here? If you were to derivate it the way it is stacked up right now, it will become too complicated. There is a u into v into a w, so there will be a u v w rule, and individually all the terms are complicated anyways. At least e raised to x square and root of sine x is going to go the chain rule way. So in the u v w rule there will be too much to be dealt with. Now on the other hand, if we were to take logs on both sides, these terms would get really simplified. Let's see how. Left hand side becomes log y, ABC, so log of x raised to 5 plus log of e raised to x square plus log of root sine x, and then we also get the powers down, so I've written both together. So you have 5 log x plus x square comes down into log e plus, remember root of sine x means sine x raised to half, so that half comes down into log of sine x. Remember log e is 1, so we have 5 log x plus x square plus half log sine x, which is to be derivated. Now when we derivate, the left hand side is obviously 1 by y dy by dx again. This will become 5 into derivative of log x is 1 by x plus the derivative of x square is 2x plus half into log of sine x, the derivative will be 1 by sine x into derivative of sine x, which is cos x. We will just transfer this y on the other side. Remember y is x raised to 5 e raised to x square into root of sine x, which remains outside the bracket. Inside the bracket you have a 5 by x plus 2x plus half cos upon sine is cot x. Now let's take another example. You have y equal to x square upon x plus 1 raised to x. So this entire bracket raised to x, so it's a function raised to a function. So let's take logs again, since it's a function raised to function. So log y will be the power x comes down into log of x square upon x plus 1. Let's differentiate with respect to x. Left hand side 1 by y dy by dx, of course. Right hand side is UV rule, so x into the derivative of log of x square upon x plus 1. Now I will apply logs inside first before I derivate. So u into the derivative of v, which I am going to write by simplifying. So log of x square will become 2 log x minus log of x plus 1. That is u into the derivative of v plus v, which is log of x square upon x plus 1 into the derivative of x. So that's u into the derivative of v plus v into the derivative of u. Remember, this v has been expanded over here or simplified over here because it is to be derivated. Here I haven't expanded it because here it is just multiplying with the derivative of x, so I need not open it out in this part. Let's see how it gets simplified. So x into derivative of 2 log x will become 2 by x minus log of x plus 1 will become 1 upon x plus 1 into derivative of x plus 1, which is 1, then plus log of x square upon x plus 1 into the derivative of x is 1. So the major simplification needs to be here. So let's take LCM. So x into x plus 1 is the LCM. X plus 1 gets multiplied with 2, you get 2x plus 2. This x goes and multiplies with this 1, so you get minus x over here. The other part, log of x square upon x plus 1, remains as it is. Now we just simplify this. We get x plus 2, because 2x minus x becomes x plus 2 upon x into x plus 1. This x, when it multiplies with x plus 2 upon x into x plus 1, will get cancelled. So we'll also transfer this y on the other side in the meantime, which is x square upon x plus 1 raised to x. And what do we get in the bracket? You get x plus 2 upon x plus 1 plus this term is written as it is, log of x square upon x plus 1. Moving on, the next question. We have y is equal to x raised to sine x into tan x raised to x. So there's a product of two terms which are in the format function raised to function, right? So obviously we are going to take logs on both sides. So when we take logs, left hand side is log y, right hand side you'll have log of x raised to sine x plus log of tan x raised to x, and then we get the powers down as well. So we do both the things in one step. Sine x into log of x, the sine x, the power has come down into log of x. There's a product, so there will be a plus, and you have this power coming down, x into log of tan x. Let's differentiate this. You have left hand side 1 by y dy by dx. Here you'll get sin x into the derivative of log x is 1 by x plus log x into the derivative of sin x is cos x plus x into the derivative of log tan x is chain rule, so 1 upon tan x into the derivative of tan x is sec square x plus log of tan x into the derivative of x is 1. We just need to simplify this a little bit. Let's see how. So dy by dx will be you get the y on the other side. Y, remember, is sine x raised to sine x into tan x raised to x. Let's just confirm that. Here you have y is equal to x raised to sine x into tan x raised to x. And then in the bracket we'll have sine x by x plus log x cos x plus x sec square x upon tan x plus log of tan x. Now let's come to the last problem. Now you have y equal to x sin x plus cos x raised to tan x plus x raised to x. So there's a function raised to a function plus a function raised to a function. There's no product, there's a plus. Function raised to function plus function raised to function. Now you might be tempted to take logs on both sides again, but remember, log doesn't go across a plus sign. If there was a multiplication sign like in the earlier sum, we would have taken logs straight away. But since there's a plus in between function raised to function and function raised to function, there's a plus in between these two terms, we cannot take logs right away. So then how do we solve this? What we do is we take these expressions individually. So I say let u be x sin x plus cos x the whole raised to tan x. I will differentiate this separately. I will consider x raised to x as v, and I will differentiate that separately as a different sum, and then I'll combine both of them into this common sum. So let's see. I've taken u as x sin x plus cos x the whole raised to tan x. So I take logs on both sides here. So u would become log of u equal to, the power comes down, so tan x comes down, into log of this entire bracket, which is x sin x plus cos x. Let's differentiate with respect to x. Left hand side is 1 by u du by dx. Remember, it's not y, it's u. So 1 by u du by dx equal to tan x into the derivative of log of x sin x plus cos x. So that will be, because it's log, so it will become 1 upon this entire bracket. So 1 upon x sin x plus cos x into the derivative of this bracket, meaning the derivative of x sin x plus cos x. So that's u into the derivative of v plus v, which is log of x sin x plus cos x, into the derivative of tan x, which is sec square x. So what do we get? 1 by u du by dx will be tan x divided by x sin x plus cos x into the derivative of x sin x plus cos x. This is uv rule, so x into cos x plus sin x into 1 plus the derivative of cos x is minus sin x. So here the sin x and minus sin x get cancelled. The second part of this expression plus you have sec square x plus log of x sin x plus cos x written ahead. So what are we left with? Du by dx equal to, we transfer this u on this side, you have this x cos x which is left because this sin x minus sin x has got cancelled, so x cos x gets multiplied with tan x, the whole divided by x sin x plus cos x, plus you have this sec square x into log of x sin x plus cos x, which I've just written as it is in the next step. Now u, you should know, is x sin x plus cos x the whole raised to tan x, so I've written that in place of u, into cos into tan. Remember, tan is sine upon cos, so cos will get cancelled, so you'll be left with x into sin x divided by x sin x plus cos x, and plus this expression is written as it is, sec square x into log of x sin x plus cos x, and that is du by dx. Then we come to the second part, which is written after plus. So we have a x raised to x. We've taken that as v equal to x raised to x. Remember, this was the very first example that I showed you. We take logs on both sides. Log v will become x log x. We differentiate with respect to x. You get 1 by v dv by dx equal to x into derivative of log x is 1x plus log x into 1. And here x and x got cancelled, so you get 1 plus log x in the bracket. We transfer the v on that side. V happens to be x raised to x, so you get dv by dx as x raised to x into 1 plus log x. Now remember, you have y equal to u plus v because you've considered the first expression in y to be u and the next one as v. So you know your y is u plus v. That's precisely what I've written here. So when I differentiate with respect to x, dy by dx will become du by dx plus dv by dx. And now we just simply plug those values in place of du by dx and dv by dx that we found earlier. So dy by dx will be, what is du by dx? Du by dx is all this entire thing, which we plug over here in place of du by dx, right? And plus, in place of dv by dx, we'll plug x raised to x into 1 plus log x. Here you go. So this was a fairly lengthy sum, but if you break it down into two parts, u and v, and do exactly as I tell you, this won't be a hassle. Anyways, I hope you've understood the examples that I discussed in this video. Until next time, goodbye.